Welcome to SanfordFlipMath. This is PreCalculus. We are wrapping up this unit on trig identities, working with double angle identities, and we are working through the Demana Waits Foley Kennedy book. We are in section 5.4. So we only have one little section of this sheet, this page, to work on, and there are really 5 of these, and you'll see those in just a minute. I'm trying to kind of narrow down the things that you need to know, and I will tell you just kind of quickly, and you'll see this in a second, that you can get by with knowing just these and not knowing these at all, because you can develop the double angle identities fairly easily. It's just, remember, any identity you don't memorize, that you don't just straight up know, is something that will take more time and more work during a test or a quiz or something like that. Okay, so just so you have heads up. Okay, all right, so let's talk about the sine of 2a. Now, okay, let me again remind you that if let's just for a second, you already know that the sine of 90 degrees is 1. It's based on the unit circle. You can do that in your calculator, whatever. And this is really the same thing as the sine of 2 times 45 degrees, and I'm just in degrees so it's easier to follow. So that really has to be 1. So my contention here is that it is not the same thing as 2 times the sine of 45 degrees. I need you to be aware that trig, just like you can't distribute across trig, you can't distribute a trig function across addition or subtraction inside where the angle is. You can't pull this 2 out here in front. It's just not, it doesn't work. And just to show you that, remember the sine of 45 would be the square root of 2 over 2. And if I multiply that times 2, well, that's the square root of 2. And shockingly enough, the square root of 2 is not 1. The square root of 2 is 1.414 or 828, this long ugly decimal, okay? So all that to say is you cannot just bring that 2 out in front. It just does not work. It is not allowed, okay? But you can think of this as the sine of a plus a. And what that lets you do then is it lets you follow the sum and difference identity. So just a reminder that we have this identity here, and instead of doing a plus b, we're doing a plus a. So everywhere you see an a, put an a, and everywhere you see a b, put an a. Okay, so remember, sine has same sign, different function. So it's sine, cosine, cosine, sine, and here's a, and here's b. I know I'm writing a, and remember it follows the same sign. Okay, so ultimately this is sine a cosine a plus, now I'm going to write this, now I can reverse the order of multiplication, so this is sine a cosine a. Well, those are the same thing, so I have one of these and another of these, so that's 2 of these. Okay, so this is a new identity for the sine of 2a. Unfortunately, cosine does not follow the same setup. Neither does tangent. Okay, so I'm going to go ahead and do one for cosine, and I'll tell you that there are a number of rearrangements for cosine. Okay, so cosine, remember the rule for cosine is same function, different sign. So it's cosine, cosine, sine, sine. Remember my cute little song. And remember what we're doing here is we're thinking of this as a plus a. Okay. And remember, so cosine has the same functions together, but different sign. So if this is plus, this is minus. And the angles are A and B, A and B. Remember they're A and A really. Okay, for this one. Okay, so cosine times cosine I can write as cosine squared. Sine times sine is, you guessed it, sine squared. Now, you need to avoid temptation here, and I know you're so programmed to think of cosine squared and sine squared as 1, but this is really cosine squared minus sine squared, not plus. Okay, so this is one of the identities for cosine. Now, the problem is this. Because of that rule we just mentioned, I can actually make some substitutions. For instance, if I subtract sine squared from both sides, cosine squared is 1 minus sine squared. So instead of writing cosine squared here, I could write 1 minus sine squared there, minus another sine squared. And all I'm doing is developing the different rules. Okay? And similarly, we could have done a different substitution, which would have created one that, the other option for this is 2 cosine squared minus 1, if we would have solved this instead of for cosine squared, for sine squared. Okay, so there are 3 different rearrangements for the cosine rule. Okay, I'm just going to do one more, and that's for tangent, and that is all of them. And I need you to see this logic here because we're going to be doing other things than besides just doubles. Okay, so for instance, so in this case, remember the rule for tangent, and this rule was one that we didn't spend a lot of time developing, but it's on the sheet and we've mentioned it. Okay, so it's tangent A plus tangent B on the top. Remember that it follows the same sign on the top. So tangent A plus tangent B. Remember that A and A this time. Same sign on the top, opposite sign on the bottom. Okay, so you have to decide if it's worth memorizing all of these rules. That's 2 of those on the top. And on the bottom, since they're connected by multiplication, I can say squared. Okay. Okay, so these are the 3 rules, the 5 rules that are considered double angle identities, and here they are, kind of typed up nice for you. You can pause and write them down. Again, these are all located in the PowerPoint that's available on my Google website. Okay? All right, so those are the rules. Okay, so what? What are you going to do with them? Well, there are really 3 different things we could do with them. The first thing we could do is make new identities, which we will do first. We could make calculations with them, which we really don't do a lot of because most of the calculations that we could do, we have other ways to do. Okay, so we're probably not really going to do that one. Okay, it's useful for that, but not as useful. Okay, and the other thing that we're going to do is solve equations using them. Okay, so we're going to focus on this one and this one for the rest of our time in this video. Okay, all right, so first up, let's make some new identities. So what do I mean by that? Well, what if I needed to know a way to calculate the tangent of 3a? Well, what I'm going to do is I'm going to ask you to put everything that you can in terms of a. Okay, so the directions might just say rewrite in terms of a. So that means you could have sine of a, you could have tangent of a, cosine of a, you could have cosine squared of a. Okay, something like this would be okay, but cosine of 2a is not. So the angles have to be a. Okay, so what this means is do the cosine of a and square that answer. What this means is double your angle to make a new angle and then take the cosine. 2 different things, different concepts, different ideas. Okay, so let's do it so you see what I mean. Okay, well first of all, how am I going to get from 3? I don't have a rule for 3a. I see rules for 2a, like, you know, here's a rule for tangent of 2a, but I don't see a rule for 3a. Okay, well, so maybe what we need to do is think about this kind of like what we were just a minute ago. What if I did 2a plus a? Now, I have a rule for addition. The rule for addition is tangent of the first angle plus tangent of the second angle over 1 minus tangent of the first angle, tangent of the second angle. Now, just a reminder, on the rule for tangent, because it comes from sine over cosine, it's the same sign on the top and the opposite sign on the bottom. Well, this says rewrite in terms of a. Well, this is still 2a. This is good. This is good. this is still 2a. Well, that means I need to make a substitution in place of those 2a's. Well, I can't just substitute tangent 2a, but I can't just substitute for the 2a, but I can substitute for the tangent of 2a. I just did an identity for the tangent of 2a. The tangent of 2a is this guy. Okay, so if you remember that, or you can look back, the tangent of 2a is 2 times the tangent of a over 1 minus tangent squared of a. Well, that's going to be plus this tangent of a all over, yeah, it's ugly, sorry, 1 minus, now this is tangent of 2a again, and I know this is ugly, but I have good news for you in just a second here, times tangent of a. Now, first of all, you need to avoid temptation, and I know I speak a lot of avoiding temptation, but doing this, that's a no-no. This is connected by addition, this is connected by multiplication, but again only for that term, and so these are not common factors. You can only divide out common factors, and none of that is, okay? Likewise, don't do this. Again, that's no. Same story. This is connected by subtraction to that 1. These are not common factors. So I know sometimes the little algebra stuff just gets people. Okay. All right. So I told you there was some good news. The good news is these are all about a now. Everything in here is about the angle A. There's nothing in here about 2a or 3a, and I don't need you to simplify it. The good news is this is done. The bad news is it's ugly, but the good news is we don't care. Okay, just there it is, leave it alone. Okay, all right, let's do another one. Okay, what if we had sine of 4a? Well, there are two ways to think about this. I'm going to go with the one that people tend to hook up with better, and there's a sneakier way. We're just not going to do it the sneaky way. If you can see the sneaky way, then knock yourself out. Just a quick hint for the sneaky way for some of you. All right, so if you understand what you're going to do with that, then awesome. If not, that's okay. All right, sine of 4a. I'm going to think about this like the sine of 2a plus 2a. Okay, so remember sine follows this rule where you do sine, cosine, cosine, sine. Now this would have been b. Follow the same sign. Cosine a. Sorry, that's kind of jacked up now. Let me fix it. Sine b. Now, if you recall, those are actually the same thing. Sine, cosine, cosine, sine, all the same angles. So I'm going to call this 2 sine of 2a, cosine 2a. Now that should look like the double angle identity, which was kind of my hint over here a minute ago. Okay, but I'm not done because it's not just about a. Okay, so what I need to do now is follow one of the rules for sine. Well, one of the rules, there's only one rule for sine, and it's right here. Okay, so 2 sine a cosine a. Okay, so this 2 is just coming along for the ride. This then is 2 sine a cosine a, and then this guy I need to follow one of the rules for cosine. Well, the problem is this. I have 3 rules for cosine, so guess which one I have to use? That's right, any one you want. So just pick one, it doesn't matter. Now, if there was something else I was going to do with this, then maybe I would pick a specific one, but it really doesn't matter. So I'm just going to pick the obvious one, which was the first one we got, which is cosine squared minus sine squared. Okay, now, are all of the angles A? Okay, so for instance, I see sine of A, cosine of A, cosine squared of A. This is cosine of A squared, sine squared of A. Everything's about just A, and again, you could simplify this if you wish, but why? You know, so the good news is everything's about A. We're done. Okay? All right, so one of the things that we do with the double angle identities is make new identities. Okay? The other thing that we tend to do with double angle identities is involving solving equations. So let's have an equation. Ta-da! Okay, so we've done some of this back from the last unit, back in chapter 4, and we did some of this back when we were first talking about section 5.1. Okay, solving. Now, the difference is that in this section, notice that the angles are not matching. That's a problem. Okay, so the angles need to match. So I can't just unsign both sides because they're not, you lose solutions. Okay, so this is again the idea that we're looking for all the solutions between 0 and 360, all the solutions all the way around. So I need to not lose solutions. Okay, so first order of business here is the angles need to match. If they don't, then this is where you're going to have to use an identity to do something. So like for instance, sine of 2x, okay, and this is one that we just learned. Okay, now do not divide out the sine, because if you divide out the sine, you're going to lose solutions. All you'll be left with is 2 cosine equals 1, and then all of the solutions that would have come from sine are gone. Okay, so that's a problem. So I'm going to subtract sine from both sides. Now, subtracting sine does not cancel out any signs. Okay. Now, I do want you to notice that there is a sign in common. So we're going to undistribute this. We're going to factor it out, not unfactor, but factor, because we're unmultiplying. That's what factoring is. And what we're left with is this. And remember that 1 comes from the fact that if I distribute that sign, I have to get that last sign after the subtraction back. Okay, and at this point, I have two things that are multiplied to equal 0. One of those things had to equal 0. So either sine equals 0 or 2 cosine minus 1 equals 0. Well, I'm going to go ahead and solve this for cosine. So adding 1 and dividing by 2. Okay, so now we need to kind of go back to unit circle kind of stuff and things like that. So either unit circle, or you could do inverse sine and inverse cosine just to. Okay, so what I'm looking for, first of all, is where is the sine 0? Well, sine is 0. Remember, sine is like y on the unit circle. Well, I see 0 here, so that's at 0 degrees or 0 radians. And it's also going to have a y value all the way over here at 180 or pi. It will also have one all the way over around here at 360 or 2 pi. Now, just a quick little note here. I need to pay attention because this guy says don't include the 2 pi. Oops, sorry. So I'm going to get rid of that one. Okay, so those are two good solutions. Now, cosine is 1/2. When the reference angle, now remember when x is 1/2, sorry, that's square root of 3 over 2. So when x is 1/2, that's a reference angle of 60 degrees. So this is going to be pi over 3. Well, now the other spot where cosine is positive would be in the 4th quadrant. So that would be at 300 degrees, which is 5 pi over 3. Now, I kind of blazed through this. If that went too fast, you are in charge of the rewind button and the pause button. Back up and see it again. Okay, I just want to do one more, and I know time is getting there, but I just want to make sure I do 2 examples of each kind. Okay, all right, so one more time. Okay, all right, so here we are. Again, the big issue is here, do the angles match? No, they do not. Now, if they match, you can just solve it. If they don't, you got some work to do. So cosine has 3 different rules. Okay, so here they are. Now, what I want to do is I want everything to be about x. Well, any of these 3 will get you something about x. But I would like to use a little strategery. Okay, again, that's not a word. I want to be strategic about this. This has sine in it. And if I introduce a term over, from one of these identities that has cosine squared in it, I really don't want cosine squared and sine mixed because if I have sine squared and sine, I might be able to factor this thing. So I'm actually going to pick this one, and the reason again is I want stuff to match. You know, trying to factor stuff that's y squared and x is difficult. You can't really do it. So, you know, unless you have other stuff working out just exactly right. So I would like things to match as much as possible. So I'm going to replace cosine 2x with 1 minus 2 sine squared x, and again, that choice was just from, you know, cosine has 3 options for the double angle identities. Okay, so I'm going to rearrange this a little bit. So negative 2 sine squared okay, and then one other thing to note here is I really don't like negative leading coefficients. I find them annoying, and so I'm going to divide every term by a negative 1 technically. Okay, and then after that now I'm set up to where I can solve. Okay, so at this point what I want to do is I want to think of this like 2x squared minus 2x minus 1 equals 0. And the thought process here is I'd like to factor this if I can. Well, I'm sorry to say this is not going to factor. If this guy would have been a 1, this would factor, or even a positive 1 or negative 1, doesn't matter. It would factor. So this thing is not going to factor. Now I know some of you are saying, yay, we don't have to do it. No, sorry, not true. What it means is we're going to follow the quadratic formula. Okay. It also means that the answers for this are going to be ugly, so I'm going to ask you to please round these to the nearest thousandth. Okay. Now, you're going to have to bear with me. This is not going to be pretty. Okay. So, quadratic formula says opposite of B. Well, this is A, this is B, and this is C. This is not hard. The thing that is hard is you're going to have to remember that this isn't x, this is sine of x that we're getting, because this is about sine and not just x. Okay, so here we go. Opposite of b plus or minus the square root of b squared minus 4ac, and you've seen me do this before. I'm very careful with the discriminant, the numbers inside that radical. So easy to make a sign error. So this is 4 plus 8, so that's 12. So this is 2 plus or minus 2 root 3 over 4, which we could simplify to. Now, again, the bad news is this is sine. This is not x. Okay. So what I need to do is work with some decimals. Okay. So let's do some typage. Okay, so I need some approximations for 1 plus or minus square root of 3 over 2. All right, so here we go. Let's go here. Let's do 1 plus the square root of 3 divided by 2. And remember, what I need to do here is find angles, and I'm going to be in radian mode. Okay, so now I'm working on the new system, so this is a little, this is kind of handy here. And remember that we're talking about sine, right? Sine of x. Okay, so 1.366. Okay, so sine of x is 1.366. I'm not going to round that number. I'm not going to retype stuff. I'm going to do inverse sine. Okay, so inverse sine of that answer, and I get a problem. Ooh, well, that is nice. I did not foresee that, but I see it now. Okay, so remember that sine is supposed to be between -1 and 1. Well, this is obviously not between -1 and 1. So this part of this is actually, I already know there's no solution for that part. Okay, so again, the calculator is giving me an error message because this particular factor gave me a solution that's really not a solution. It's kind of one of those extraneous things, right? Okay, so this particular one doesn't work. Now, remember, we've only done the plus part. There's still a minus part. So I need to go back and do this again with the minus. Okay, so I'm going to go up and I'm going to grab that. Now you can, if you don't have the new system, you can still do that by hitting second enter, and then you can actually go in and edit that calculation. So there's minus. Okay, let's try it again. So this one's going to work. So I'm going to do inverse sine of this number, this answer, negative 0.366. Okay, let me write some of this down. Okay, so one of the solutions I get from this is negative 0.375, I'm going to call it. Negative 0.375. Now remember that what I just got was this angle. That is not between 0 and 2 pi. So I have to do a little bit of work here. Okay, so really what I'm going to have to do is I'm going to have to do 2 pi minus 0.375. Now in the calculator I'm going to write 2 pi plus my answer because it's already negative. Okay, so let me pop back over to the calculator and do that. Okay, now I know this is moving right along, but all of this stuff is stuff that we've actually already done before. It's just been a while, 5.908. Okay, so remember that you are in charge of that rewind button. Okay, so that's the fourth quadrant angle. Where else is sine negative? In the third quadrant. I really want to go back and grab this and make it a reference angle. And what I'm going to do is pi plus a positive 0.375. Okay, so I'm going to say pi plus, well, I'm going to go up and grab, too far, this angle, but this is wrong. This is plus a negative. And I want to make that a positive. Okay, so I'm just going to delete that negative. There are other ways to do that. 3.516, a little more than pi, 3.516. 3.516. There is my other solution. I expected 4 solutions. I really only got 2 because the one factor didn't give me any. All right. Why was this in this section? Because it started off with that 2x and just an x, and that was a problem. Okay? All right, well, I went way long. This was an ugly example, but, you know, that was for you, Jeff. I wanted to make sure I got an ugly one in there for you. Okay? All right, well, thanks for hanging with me. SanfordFlipMath, time to be done, and then some. Bye.